streets. The predominant tree species in New York City are London plane, Norway maple, and Calgary pear. And these three species constitute almost 39% of the tree population. Okay, these are some facts about the New York City's urban forest. So, for example, in New York City we have 24% of land covered in trees. We have 2,202 tons of annual pollution removal, which accounts nitrogen dioxide, sulfur dioxide, ozone, and particulate matter. We have 1.35 million tons of annual carbon storage, 890 million gallons of annual stormwater intersected, and the total annual benefits from street trees totals $122 million, which is a very consistent amount of money. And in New York City, there is a project called 1 Million Trees. 1 Million Trees is a citywide public-private program with the ambitious goal of planting and caretaking 1 million new trees across the city's 5 boroughs on the next decade. And precisely, they are supposed to plant 1 million new trees by 2017. And so 1 million trees is one of 127 Plan New York City's initiatives to strengthen New York City's urban environment. And Plan New York City is the biggest plan ever undertaken by an American city. The city will plant 60% of trees in parks and public spaces, and the other 40% of trees will be planted on property owned by private organizations, owners, and community organizations. The number of trees planted so far is almost 500,000, and this is a considerable amount of trees if we think that the Million Trees project started in 2017. So up until now, just in a few years, they have already planted 500,000 trees. And part of the 1 million trees is the New York Restoration Project. It was founded by Beth Midler after finding a neighborhood neglected and full of litter. And the aim of the New York Restoration Project is to restore, utilize, and develop under-resourced parks and the community gardens across the city's 5 boroughs. This in the picture is one of the first planting I personally did with the New York Restoration Project at Kings Bay in Brooklyn. And you can see how much better this backyard looks after the planting of these little trees. The areas where data have been collected for this study were chosen by the New York Restoration Project to check the condition of the trees planted in October 2010 for the Bronx and September 2009 in Queens. The first study area is located in the Bronx and precisely in Parkchester South. The area is surrounded by tall buildings and dense house construction, and the number of trees surveyed is 130. As you can see from this chart, the most common tree in Parkchester South is a Calgary pear, followed by the silver linden. The second study area is located in Queens and precisely in Far Rockaway. The area is really close to the ocean, so this area has a different environment as there are fewer buildings compared to the area in the Bronx. And the number of trees measured in this area is 203. The most common species also here in Far Rockaway is Calgary pear, followed by the honey locust. The tools used for the collection of data are a caliper. This caliper has 2 different scales to measure the diameter either in inches or in centimeters. I used the inch scale. Paper form where data were noted down, and I3 streets for data analysis. And this tool deserves a further explanation. So I3 Streets was developed by the USDA Forest Service and numerous cooperators. Is in the public domain and available by request through the I3 website. So I3 Streets is a street management and analysis tool for urban forest managers that uses trees inventory data to quantify energy conservation, air quality improvement, CO2 reduction, stormwater control, the value of annual and aesthetic benefits and property values. So this tool here, I3 Streets, makes use of a sample or complete inventory data to quantify and put a dollar value on the trees' annual environmental and aesthetic benefits. So I3 Streets promotes a better understanding of the benefits and the services provided by community trees and helps justify investment in stewardship, operations, and maintenance of the elements of the urban forest. The foundation of I3 Streets is based on reference cities, and this means that when the urban research the urban forest research designed this model, they conducted intensive research in 16 different cities to represent an aggregation of 45 climate zones within the US. Here on the map you can see the reference cities, and the term reference cities so indicates that the data were collected in those particular reference cities. So if you are within one of those zones, you are basically making some assumptions saying that your trees are the same species composition, same growth rate, similar climate and soil, same length of growing season, and in addition you are saying that there are similar management practices and things like original prices are similar. So how this model works? So in those particular reference cities, there was an enormous amount of data collected to identify the 20 predominant tree species in those regions, and so a number of a different number of tree attributes were taken. So the idea behind this was to develop a predictive model based on regression equations. So the user in the end has only to use structural information such as the species, pH, and condition for the model to determine the canopy metric, so to say, the size, the age of the tree at a certain point in time, and also tying in the functional benefits at the point in time of the tree's age. So one of the best advantages of this model is that you need just species and dpH and condition as a starting point for an I3 analysis. So in I3 Streets there are basically 4 phases. The first phase is getting started. You have to collect. You have to, if you have an existing inventory, you are really close to the finishing line. Otherwise, if you don't have a complete inventory, you need to conduct one. And in some cases, you may want to conduct a sample inventory, or you can conduct a complete one if you have the time and resources. And in this first phase, you have to add some inputs such as city data and benefit prices, of which I will talk about in the next slide. And in the second phase is stuff that is done on the computer desktop, setting up the configuration of the data you want to collect. And as I mentioned before, it would be as easy as simple as species and dpH and condition as a starting point. And this here, I just wanted to, this is one of the dialog boxes of I3 Streets. I just wanted to pop on some of this here. And here basically in this dialog box you choose the data you want to collect for your study. And another dialog box is the benefit prices. And you can adjust these benefit prices and so, for example, because some of these benefit prices may have changed since the model was first made available. So, if I know my, for example, my local electricity prices, if I know my local natural gas prices, this is an opportunity to make my model, my analysis more locally relevant. And phase 3 is out in the field. You go out in the field and you collect the data. And so if you have a PDA, then it will be less time consuming. Once you have to upload, you have to enter the data. Otherwise, you have to use paper form, and that's what I did. And with I3 streets, there is not a pre-designed paper form. It's just really a matter of setting up a form with 3 or 4 fields. And one important thing is that you have to decide ahead of time how you're going to deal with the tree measurements, trying to lay out those parameters so that there will be consistency in the data that will be returned just in case you're working with a team of volunteers who's collecting data with you. And the phase 4 is running I3 streets. So if you have used the PDA, then you upload your data. Otherwise, you have manually enter the data in the model, which is a little bit time consuming. And so you check for errors, and once everything looks good, you can run the I3 analysis. And it's instantaneous in terms of giving feedback, so you can look immediately at your reports and you can export the results. And these here are the results of my study. Here we have the environmental and monetary benefits of these little trees in Parkchester South. So I'm sure you read my thesis. So, for example, the aesthetic benefit you can see is the most relevant, and these little trees provide total annual benefits, $4,202 of total annual benefits. Instead, in Far Rockaway, these trees provide also great benefits, environmental and monetary benefits of these little trees, and the aesthetic benefit is always the most relevant, and there is a total annual benefits of $4,856 in this area. So if we think, and this is amazing because all these benefits were not in those areas until a couple of years ago. And these little trees add such a great value to the pre-existing urban forest. In addition, as these little trees grow, they provide more benefits. So the more they grow, the better, because they are going to provide more benefits in the future. And so it is really important to care about these little trees for the all benefits they provide. And then there is the importance value is another feedback of I3 streets. It depends on the dimension and of the tree and canopy cover. So the bigger the tree and the canopy cover, the higher is the importance value. So for example, in Far Rockaway, we have a total of 32 calorie per trees. They have a canopy cover of 481 square feet and an importance value of 1824. Instead, in the same area, we have a total of 16 scarlet oak trees. They provide a canopy cover of 1,140 square feet and importance value of 22.6. So this suggests that the losing scarlet oak due to pest or disease would be more significant than losing calorie per trees. And also the relative performance index expresses the condition of the trees in a particular area and relates the overall condition of a species in relation to all the others in a survey. So any value higher than 1, here you can see in this table the relative performance index. So any value higher than 1 suggests that the species is doing well in the area. So for example here the species that have good conditions such as calorie pair, little leaf lean and Japanese Zarkova have a high relative performance index. And instead in far away the two species that have the highest relative performance index is Ginkgo and the English oak, while we consider other species such as the London plane tree and both cypress and the dogwood. They have a really low relative performance index, and this suggests that these trees are not doing well in this area. And the relative performance index is really important because it can help forestry managers in future decision making. And what was really amazing is that in this area, 35% of the trees were dead. And there are 4 possible hypotheses for the death of so many trees. The first hypothesis is that in this area there is a strong wind most of the time, and I personally noticed during my survey, my multiple surveys, that strong wind blows most of the time. And so you can see this sloping tree, this dead sloping tree, and also you can see the trees that belong to the pre-existing urban forest that do not have a natural shape due to the strong wind. And in addition, this is a marine environment, so moist air is very salty. The second, here you can see another sloping dead tree is per calorie per tree. And the second hypothesis is that in some areas the soil is really sandy, therefore has a scarce capacity of water retention. And soils with a scarce capacity of water retention can lead to many problems for trees. And especially for young trees such as these ones. Because they need a lot of water, especially the first year after planting, the most critical for their survival. And the New York Restoration Project and the park departments partner with the local community blocks to make sure, and these local community blocks have to take care of these trees, so that they have to water them, for example, once every 2 weeks. But it looks like no one took care of these trees because many of these trees are dead. And the third hypothesis is that there is accumulating in groundwater in some areas, and in fact, the Far Rockaway, the western part of Far Rockaway is not connected to the sewer, to the city sewer. So the domestic wastewater from houses, from washing cars, from that enter the sand. So domestic wastewater discharges into septic tanks, which eventually discharge in really effective leaching fields. And so the end result of all this situation is that the soil gets saturated with fresh water, and so accumulating groundwater may represent a serious problem for especially for some trees that do not tolerate water stagnation, such as this tree in the picture is a dogwood, and the dogwood tree does not tolerate water stagnation. And also the hypothesis number 4 is suspected vandalism in this area there were many trees were broken off, and also this tree here looks like someone tried to pull it out of the ground, so it looks vandalized. And the vandalism hypothesis can be proved by the type of correspondence that the New York Restoration Project and the Parks Department received from 2007 through 2009. And in the red circle, you can see that most leather were complaining leathers. And here this table, we have the complaint categories. So, for example, at 33%, we have replacement, objection, and in this category, these complaints are brought by people who believe that the planning process will damage the utility line, and that the utility line can be damaged as the tree grows. And also, for example, we have police objection at 24%, and this in this category are people, are residents who state they didn't want a tree, they don't like trees. And in this map here, citizen complaints, landscape block planning locations for New York City from 2007 to 2009. We can see that there is the density of citizen complaints highlighted. And in this area here, where part of my survey was conducted, there is a high density of complaints, and this type so vandalism can be associated with this type of dissatisfaction. So the death of so many trees result in a loss in investment. The planning of cost of a tree depends on where the tree has to be installed. It ranges from $250 in parks and lawn areas to $1,000 on sidewalks where concrete has to be broken. In my case, all the trees were planted on a lawn area. So the estimated loss in investment for the trees in this area is $16,500. So in conclusion, urban forest provides outstanding benefits, and so trees create a healthier and more livable environment for everybody. So paramount is their care and the supervision in order to ensure their survival. And all the benefits that trees provide are not so obvious to the average citizen, so there should be more information regarding what urban forestry is and what types of benefits tree provide. And iTree Streets is an outstanding tool to quantify the benefits of municipal street trees, and this tool should be used as an advocacy tool. And also, the New York Restoration Project is a great organization, but it needs to improve in some aspects. Data, for example, data from previous surveys were not well organized, and also sometimes species on the map didn't match with species on the ground, making the survey more time consuming. And more studies such as this should be conducted in towns and cities all over the world. It's really important to quantify the benefits that trees provide, especially when they are on public property and provide the benefits to all. Yeah, that's it.